Hey,
Everybody here? Hey, everybody is here.
Hey,
Hello,
we're here.
everybody.
Bells ring and the banners fly.
Hey, diddly-o, neighbors.
Here we go. Okay, well, good evening, everybody, and welcome back to our Sunday night offering of Astronomy Entertainment, the Sunday Night Astronomy Show.
yay! That's a wave.
My name is Chris Carwin. I'm the creator of the social media channels known as Astronomy by the Bay.
Yay!
I paused for that one.
No, there's more though. There's more.
There's more. I'm also an amateur astronomer and a member of the Royal Astronomical Society of Canada.
Yeah.
Hey. Okay, I'd like to welcome back my two regular. I got to welcome back my two regular co-hosts, Mr. Paul Loman from the Moonshot Observatory in Littlehampton. Paul, good evening, sir.
Hello.
Mr. Mike Powell from the PFO Observatory here in St. John. Mike.
Yay!
Hey.
Yeah.
And we'd like to welcome all of you tonight from YouTube and Facebook land. Thank you so much for your support. Okay, on tonight's episode of the Sunday Night Astronomy Show. Right now, Saturn and Venus are in Aquarius. Jupiter is nestled between the horns of Taurus, and you'll find Mars near the heads of Gemini the twins. If you were given this information, would it make sense, and could you find them? If the answer is maybe, then we're here to help. Constellations are the roadmaps to the night sky treasures, and the more you recognize them, the easier it is to find those treasures. Agreed? Okay, agreed. Page 2. Now, this week, we continue our discussion around constellations by inviting back our local constellation expert, Mr. Curt Nason. Curt will help us explore the constellation of Monoceros, the unicorn, and the treasures we can find within its borders. Welcome, Curt. Welcome back, sir.
Well, thank you very much. Glad to be here.
Good to have you here. Okay.
The check is in the mail.
I have a question. Can I ask a question?
Sure, go
I
ahead.
just did.
Is it Monoceros or Monoceros?
Monoceros.
Oh, it is. Like
Yeah.
rhinoceros.
Have you ever been to exactly?
Rhinoceros.
So it's not a dinosaurus?
It's the Monoceros.
Monoceros.
Okay. Perfect. So you learned something already. Also,
Do I have to
tonight,
finish it now, or
yeah, that's good. Thanks,
that's
Curt.
pretty much
Come on
all
the
I
show.
had?
Appreciate it. Okay, also tonight, Binocular will return with another fine binocular target to enjoy. Paul will be delivering another Rosanna's Fun Fact episode.
I Willoris.
I will, of course. I'll have a quick look at some upcoming events to start the month, along with the reveal of your along with the reveal of your photo submissions. And tonight, let's get started in tonight's program and a look at the constellation of Monoceros.
Thank you.
Monoceros.
Monoceros.
Expialidocious.
Is it Galapagos or Galapagos?
Depends which part of the island you come in from.
Potato. Record and record.
Get up there. All right, Monoceros the unicorn, or the unicorn. So I guess the first question is, why pick a constellation that you can't see? Well, good question. It is it's one that you can't see really much. If you're outside of a rural area, you've got about as much chance of seeing the constellation as you do of actually seeing a unicorn. But there are some interesting things in there, particularly for imagers. And it actually has a lot of stars in there. It's just that not very many of them are visible to the naked eye. As you can see, we've got the Winter Milky Way coming up through here. So when you get the Milky Way coming up, you're going to have telescope or binoculars. You're going to see a lot of stars in there. Plus a lot of things that you do see in the arms of the galaxy, like star clusters and nebulae. So we've got some of those in there. We're just going to have a look at a few of the more common ones and get in there. So we can see, if you want to try to find Monoceros, best place to do is start off here with Orion, just to the west of it. And you've got Gemini the twins up there. You've got, maybe the best thing is just go with Procyon here in Sirius and up in between them. And if you see any stars in there, they most likely belong to Monoceros. Now it's got its three brightest stars are down here pretty much in the hooves. There's this alpha, beta, and gamma in there, and they're in their fourth magnitude, pretty much about halfway between fourth and fifth. So they're not very brilliant, but you should be able to pick them up from like a suburban sky with the naked eye. You got a bunch of the other ones around there, as Chris was mentioning. Here's Taurus in here, and this is where Jupiter is right now. And it's in retrograde, and before too long, it'll stop and start moving up through here and heading toward Gemini, where it'll live next year. And Gemini in here, outside of this picture, but we got Castor and Pollux up here in the head of it, and Mars is just slipping down past them. They should be still in a line there tonight, but it's going to be moving slowly while it's in retrograde and backing up into Cancer again. So there's two of those bright planets. I can't point out the other ones right now. They're way off the map. All right, you got Hydra over here trying to tickle the unicorn's butt with his tongue, and Canis Minor, the little dogs, are riding on the back of the unicorn and getting a free trip. And you got Lepus the hare down in here. We'll be visiting this area maybe a little bit later on as well. All right, so that's generally where to find it. Just get a dark sky if you can and look up between Sirius and Procyon and use your imagination. All right, the stars. So Alpha, Beta, and Gamma. Monoceros, I pointed out Alpha, Beta, Gamma. Actually, Beta is slightly brighter than the other two. They're up 3.8, 3.9 to 4 magnitude. So they're not brilliant, but they're okay. And you might look at here, you can see the Milky Way coming up here. You see all these little dimmer stars. You pick those up with a pair of binoculars. And you might see some color in here. So here's the unicorn snout. You see some little pink there. Maybe he's got a cold, but we'll see what that is. There's a piece of blue up here. You see blue, that's usually a reflection nebula. So you get some hot stars in there within the clouds, and the blue light coming from them is reflecting off those clouds. That's a reflection nebula. You can see another one down here, a little bit of red here. So we're going to be visiting those and a couple of other things. So none of those stars are really bright, but there is one, particularly for Canadians, there is one particular star that's quite famous, or at least the person it's named for is quite famous. And that's Plaskett star, named for a Canadian astronomer back in the early to mid 1900s, John Stanley Plaskett. And he was the first director of the Dominion Astrophysical Observatory. The telescope went into service there around 1918, 1919. And it would have been the largest telescope in the world, but it just got beat out by one of the ones in the States. They were both made about the same time, but the other one, when in the States, I think it was 100-inch, went into service just before that. Now, Plaskett, he's one of the people that had determined the rotation rate of the Milky Way. His number one thing he was looking at were these spectroscopic binaries. So binaries are two stars orbiting each other. We can see some of those, like Algol is a famous one. But these are it's a binary. Spectroscopic ones are the stars are just too close together to resolve them with the telescope. But by using a telescope and a spectrograph on it, a spectroscope, you can see the Doppler shift, the elements of those stars. So it tells you you can see where one star is moving back and the other one toward you, and then they swap like that. So it tells you there's a binary star there. So this star is Victor 650, discovered in 1922 by Plaskett when he was taking spectroscopy of different stars. What made that one stand out, at the time they thought it was a huge star of 100 solar masses or more. And they always thought that a star could never be that big. But by doing spectroscopy on that, realized it's actually two stars, two very massive stars, roughly 40 to 60 solar masses or so. And that was the largest spectroscopic binary until they realized that Eta Carina was also a binary star. That's the one that it got very, very bright. It became the second brightest star back in somewhere in the 1820s and stayed that way, then faded out again. Took another burst up around the 1880s. and now it's down below. Well, I've never seen its southern hemisphere, but it's not nearly as bright as it was. But if they're going to lay bets on what might be the first supernova, that would be one of the leading ones. And Plaskett, he was the president of the RASC in 1914, 1915. Okay, so this is where it is. Now we can see three stars up in here. Maybe none of them are really bright, barely naked eye made from a dark sky, except maybe that one. 13, 15, and 16 Monoceros, or Monocerotis. And Plaskett star is just not too far off here from number 13. So you can maybe pick these two out and take a little right angle turn down this way. Or if you're into this area looking at this particular thing, which we're going to visit, maybe just come up a bit from that and you'll see Plaskett star. Now look at some of these deep sky objects. And it's got one Messier object in there. That's Messier 50. And it's a good size open cluster. And it's NGC 2323. To remember that number. That used to be my old basketball number in high school, just the 23. And it's about half the size of a moon, and roughly around magnitude 6. So it's easy to pick out. Maybe in a really dark sky, you might get hit of it naked eye. Now, if you're out there with binoculars, the best way to find it is just find Sirius and Procyon and go from Sirius up to Procyon about 40, just under 50% of that distance, and it should pop in there. And that's how I think most people will find it. Using the telescope, maybe go to Sirius up in here, then come up. There's an arc of stars here that makes the top of the dog's head. And you see it's just about 4 degrees up this way from this star in here. So you can see your tail red circles, and that's 4 degrees across. That's one way to do it. And you see a picture of it here, so there are a lot of stars in there. It's an easy one to find. Good binocular object. And another one here is Caldwell 54 from Patrick Moore's Caldwell catalog. I think that was his middle name, his mother's maiden name. So he didn't name them M objects because Messier already took that, so we wanted to see. And it's a list of 109, 110 objects that didn't make the Messier list. And we've got one in the RASC catalog, RASC handbook, finest NGCs, and a lot of the Caldwell objects are also finest NGC. It's also listed in the Colander catalog and the Malay catalog. Right, so it's not as bright as M50, but it's magnitude 7.6 and just a little bit smaller. But again, a nice dense cluster in there. So if we go here, there's the alpha star in here. And we can see it's just over 4 degrees. Here's the NGC 2506. And so just over 4 degrees away from the alpha star. So we pick the one up here in the tail, and maybe not quite a right angle, down at just over 4 degrees, and you can pick that one up. 7.6, dark sky, you can get it in binoculars. Yeah. How many times you image this, Paul? The Rosette Nebula? Lots, I bet. And so this is one that's very beautiful one that is very popular imaging target, and it's in the finest NGC list here in the Observer's Handbook, and it's number 32. You get different NGC numbers here with it. So when you get something big like that with the nebula, they don't, when they first discover it, they don't always get it the first time, see the whole thing. And so it gets an NGC number, and as other people look at it later on, they pick out more and more of it. So some of these will have 3 or 4 brighter areas in them. Each one of them gets its own NGC number, NGC being the new general catalog. It's roughly magnitude 9, and it's large, about 1 degree, just over 1 degree, so 80 arc-minutes by 60. It's a difficult one to see visibly. You really need a dark sky, and you certainly want to use a filter for that, like an oxygen 3 filter, to make that pop out a little bit better. Now, I had to look at it, it was around 2002. It's down at Prince of Wales. I was using a C8. And with C8, I wasn't star upping with that. It's using the setting circles to get to where I wanted to go. It's not quite as easy to star hop with the C8 like that. And it's all manual. And so I had a look at it. I looked for the cluster of stars that was in it. And those cluster stars is NGC 2244. So if you can get into this area, this is Epsilon, which is sort of the top of the top right, more or less, of the lines there at the stars of Monoceros. And just come off a couple of degrees to the east of that, and you're into this area. And you'll have that star cluster there. And then with the, say, the oxygen filter in there, maybe with a low magnification eyepiece, you get a wider field, and just trace around in there and see what you can see. Now, when I did that, all I could see was maybe just, I think it was the northwest side of it. It's probably the brightest one. I couldn't pick out anything else, but I made a claim, okay, I did see it, or at least a third of it or something. I think I tried again maybe 4 years later, and I wasn't good as good at night, and I really couldn't get it very well that night. But it's one of those ones that's worthwhile trying out, a difficult object. It's the bigger your telescope, it's better going to be, and you have a really dark sky and use a filter, particularly an oxygen 3 filter, and you might have some pretty good luck at it there. Now, this is what you're going to see in your telescope. If you've got, well, it's going to be this is an image, but you might see some of the brighter areas in here. Right now, if you're using imaging, you get the color, the filters in there. It's one of those beautiful things that pops out, and you get the stars there in the middle of it. Right? And Rosetta is sort of a reddish rose-like pin that goes on, so that's where it got its name. We also have another NGC finest object here, not too far away. This is Hubble's Variable Nebula. It's a neat one to look at. It's an emission reflection nebula. It's that blue one I pointed out earlier. No, it's over here. Sorry, it was over here, 2264, and that's 2261. Yeah, it must be the one up here. No, here it is. Sorry. Just above the eyebrow. You're not going to see the eyebrow. Depends what kind of telescope you got anyway. That's going to be a dark area in there. All right, so this is where Hubble's Variable Nebula is, and it gets that name because it changes its brightness over sort of a long period of time. And people go in and look at it, estimate the magnitude of it, and then somebody else is in later and sees it's changed. Now, if you go on the Google that on the internet, they've got a picture of maybe over 20 years where they've put it all together, and you can see the nebula sort of waving in brightness like that. So the very bright hot star with the nebula around it, the clouds, and they're orbiting around that star. So you're going to be seeing different areas of that. Maybe it's thinner in one area than another area, so more light comes through. The darker one comes in, and you get the less light. That's what's changing the lighting in there. You do get nebula like that. The most famous one is probably the Epsilon Orgy up in the, if you look just off from Capella, you got those 3 stars that make the Haiti or the kids. And the one at the point of that is Epsilon. Every 27 years, it seems there's a dark cloud come in front of that, and its brightness dims by a factor of 3 or so. And that happened just like 4 or 5 years ago. All right, so this is it. And when you look at it, and I looked at my notes there today when I saw it, and I had it elongated, it was noticeable. So it looks like a comet. You put enough magnification on it, that's what it'll look like. And there's a very bright star there, Monoceros, which is giving the energy for that reflection nebula. Right, so while we're up there, then maybe you want to take a little run up into here, or from here up into here, and see what we get. This is the Cone Nebula, and this is another one that gets imaged a lot, and not just this area, there's a surrounding area of that. That's very good. You get 2 or 3 different star clusters in there, plus other nebula. So this is a dark nebula coming up here. Now, it reminds me of Shai Hulud, the sandworm in the Dune books, and Dune movies, and I guess the Dune series now as well. But looking at it today, This also looks like the Martians on Sesame Street. Moo.
Oh,
Dope, 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 dope. Dip, 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 dip.
Yup, 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 yup.
The colors aren't there as much, but
oh man.
it's a good one to look up. So there's a cone nebula. So here it is again.
Yeah.
And star right about here, this is the top of the tree of the Christmas tree cluster. So that comes down here and makes that triangular shape there. Right. Oh, I guess it comes down this way and across here. Then there's a brighter star down here that forms the base of the tree. And so that's a Christmas tree cluster. You get another look of it here. There's the cone. There's the top of the tree. Comes down. And I realize I haven't actually gone out and looked at these things. So I'll maybe make that something to do this year, this winter. You got that one in there. Plus, in here's the Fox-Fir Nebula. And somewhat, depending on what you're using for your camera and the filter, it does have the same color in these ones, pretty much as a fox, somewhat. Now, a good picture to see it here, it's a black and white one. So there's the cone, there's the Christmas tree cluster in there. Now, with this, you can also pick up a star cluster in here. And it's not all that visible in the telescope, but with infrared telescope, it really pops. And we call that the stellar snowflake cluster. Now, the Fox-Fir Nebula up in here, now think about this. I can see the fox's face in here. There's the snout, there's his nose, there's the two eyes, and the ears coming up here. So if you got a pretty good imagination, that head sort of jumps out at you. And the coloring with color image somewhat resembles that of a fox.
What was that movie from? It was an animation, and at the beginning of it, this thing that looks like that with the two long fangs was chasing the big nut, the big walnut.
I remember that. I don't think I've seen that one.
Like a dinosaur. It's kind of like a dinosaur movie.
Anyway, I don't catch any of those movies.
An animation from Disney. That's exactly what he looked like.
Yeah,
Okay.
the voice from Everybody Loves Raymond.
Right. And see, they got something else there. Oh yeah, much image one as well. I don't know if you've done this one, Paul or Mike, but Seagull Nebula. And here, it's not the unicorn here. This is Canis Major. So there's Sirius. There's the top of the head there. So here's M50 up in here. Right now over here is the Seagull Nebula, and actually the whole nebula will expand, will cross the boundary into Canis Major as well. All right, so you got several NGC numbers in here. So the head of the seagull, this part in here is index catalog 2177. And you got two or three other nebula, NGC nebula numbers in here. And the NGC 2327, I believe, is this reflection nebula in here. And that's one that's across the border into Canis Major. Right, so there are some of the things to pick out. Some good imaging targets, and maybe some challenging nebula in there for your telescope, but some open clusters that are fairly easy to see, binocular targets. All right, so some of you are wondering, maybe, hey Curt, where's the stories about this? Where's the old Greek mythology of the unicorn? Well, there isn't any. And the reason for that is it was made up by Petrus Plancius, who lived in the late 16th century, early 17th century. And there were several astronomers in around that 1600s, 1700s, 1500s. At that time, they were getting explorers coming back from the southern hemisphere. Whole new sky down there, some stars they hadn't seen before. And Plancius, he had crew that went down. He trained them to not take pictures of the sky, but record the sky and come back and you look at that. And he made up a bunch of constellations based on what they brought back with them. And so he's got these ones that have been accepted by the IAU, and these are some of the official 88 constellations now. There's some other ones he made up that didn't make the cut. We've got Apis, the bird of paradise, He's one that came up with Camelopardalis, the giraffe. It's up in our northern hemisphere. Columbus the dove, which is just below Lephus the hare, which is just below Orion. Goose the crane. Hydrus the water snake, the male water snake. Hydra, which is just off from the unicorn, just east of it. It's a female water snake. Indus the Indian in that area. Monoceros the unicorn, Musca the fly, Pavo the peacock, Toucan the toucan, and Volans the flying fish. He made these ones all up, and I don't know what they all look like. I haven't been down there, but I have seen a few of these. Of course, Monoceros and Columbus and Camelopardalis. And so, since this is only about 400 years old, you're not going to see it in any Greek mythology. Right? So, I wonder if there's any other mythology that would have something about the unicorn in there. So, I did some scrambling around, looking up things here and there, and I ran across an old book on Iberian legends up around Ireland. And my reading of ancient Irish or Erse is Gaelic is not very good, but I think I've got it translated. Read you a bit about what's in that book, and this is actually a poem, and it goes off the same as the Greeks. A lot of the Greek mythology is in epic poems by the original Homer, the Iliad and the Odyssey, Roman Ovid, the Aeneas mythology there. So this is one of those epic poems as well. I'll read the beginning of it. A long time ago, when the earth was green, there were more kinds of animals than you've ever seen that ran around free as the earth was being born. And the loveliest of all is a unicorn.
Yeah.
So this is some ancient Greek text, and I think I've translated it properly, or ancient Gaelic text. All right, so is this possible that the unicorn up there came from that ancient text? Well, there's another guy that made up a bunch of constellations. In fact, he made up the entire northern and southern hemisphere. Right? Julius Schiller. So he's got it. So the northern hemisphere constellations are all from the New Testament, and the southern hemisphere ones are all from the Old Testament. Right, so it's Coelum, Stellatum, Christianum. All right, so one of those constellations is Noah's Ark. All right, and you can probably imagine what Noah's Ark is. Right, that's going to be this. Now, this was in Ptolemy's 48 constellations that he had, and that was I think he got most of those from Hipparchus from about the 2nd century BC. And so he had 48 constellations, but this one by far, it's Argonautica, and so it's the Argo. Jason the Argonauts had this boat. Right, so this was a big one. And so getting around the 16th, 17th century, this 18th century, Lacaille thought it was too big. He was down in the south as well. So he proposed to break that up into 3 constellations. And so we've got the sails here are Vela. We've got the keel underneath it is Carina, yeah. And up in here at the back of the boat is the aptly named poop deck. Okay? And I assume that's where they went to have a crap off the end of the boat. Maybe that's why they call it the poop deck. You learn a lot of things taking astronomy. All right, so he proposed that. Some people didn't take it, but in the 19th century, John Herschel, Sir John Herschel, son of William Herschel, he also was decided to go with those 3, and he proposed another one as well because there was a mast here and on the boat, and he thought that should be a Pyxis, which is the nautical compass. Right, so in the 1920s, then the International Astronomical Union accepted those 4 constellations that used to be part of Argonauticus. So you got Pyxis up in here, the nautical compass, and we got the keel, we got the poop deck, and we got the sails. Right? And they're all in there as part of the official constellations. So here we've got an arc. Now, what else we got in here? Well, we don't have any green alligators from the poem, and I didn't read. We do have maybe the snake is green. We've got the hydra here, and we've got the hydras down below. It's often on the place here. So maybe pretend those are alligators. Long neck geese. Well, down here, here's another one of Plantius's. This is Grouse the crane. It's got a long neck. Cygnus the swan is a long neck. So there we got two long neck geese, sort of. Humpyback camels, camelopardalis. No chimpanzees actually, but cats. Yeah, we got cats up there. We got two lions. We've got a lynx, and there used to be a constellation, is no more, called Felis, the cat, the wonderful, wonderful cat. We don't have any elephants, but we got two bears. We actually have four dogs, Canis major and Canis minor, and Canis vanitici up here. Right, so maybe you can pretend they're wolves. We got a pair of fish in Pisces. He also has several fish here in the southern hemisphere. You have two centaurs. So maybe these all match in, and this is where all this Gaelic mythology comes in that I made up. Right? So I think that's where it all came from. And maybe I'll just finish it here with the last verse of that. The ark started moving and it drifted away. The unicorns looked up from the rocks and they cried. Oh, let me start that one again. It's hard to read this Gaelic stuff.
A little more Irish accent there, Curt.
A little more Irish accent, sorry. Let me go get a nip of something first and I'll come back. The ark started moving, it drifted with tide. The unicorns looked up from the rocks and they cried. And more light. All right. Then the water came up and they floated away. And that's why I've never seen a unicorn to this very day. And when it's raining, you're not going to see the Monoceros either. All right. So I think that's all I got. Yes, it is. So that's the end of this tale, boys and girls.
Now, can you sing that, Curt, or can you just?
Well, I don't want to get kicked off here.
Okay.
Somebody did it one time, yeah.
There
you go.
That's him.
Yeah, Ice Age.
Yeah, that's why I never pick acorns.
It's funny. One of my Bono Bud target tonight was on one of your lists there.
Okay.
And it doesn't exist as a constellation anymore.
All right.
But it's still a Bino target.
Okay. I just got
Here it says they must have been drinking a lot of grog to see all that in the night sky.
Oh,
Green
yeah.
beer, green beer.
feeling groggy.
Thanks, Curt.
Well,
Good stories. A good legend anyway. Why not?
Why
somebody's
not?
got to make the crap up.
Sure. It's about as rare as a unicorn. So, well done. Did we get to the nebula that was hanging out of his nose there?
Yeah, that was the rosette.
Oh, okay. Well, I called it the booger nebula, probably.
Yep.
He had nosebleed.
Yeah, there you go.
Unicorn snort. Yeah.
Yeah. Okay. Thank you, sir. Mr. Powell, could we move on with the vinyl bud, sir?
We can. As I find the right screen to share here.
Okay.
Screen number 2. This is the one I want. You should see them coming up there. And again, this was once a constellation, and now it's just a Bino Bud target. And the difference in this Bino Bud tonight, instead of me reading something, I'm going to play a little clip that explains it all for you. So, binocular target of the week this week is the northern fly. Yeah, flying on the snow, right? Northern fly. And you go, northern fly? Well, let's see if this explains it. Hold on and see if we hear it.
For 3 centuries, an insect buzzed around the backside of Aries, but the ram got rid of the pest a century ago, claiming the stars as its own. The buzzer was created in 1612 by Dutch astronomer Petrus Plancius. He took some faint stars from an empty region near Aries, He named his new constellation Apis, Latin for bee. But there was already a celestial bee. So in 1687, German astronomer Johannes Hevelius renamed Apis. He called it Musca, the fly. And in 1822, it was adjusted to Musca borealis, the northern fly, because there was already a fly in the southern hemisphere. A century later, though, astronomers replotted the skies. They got rid of several constellations and gave their stars to others. Musca borealis was one of the victims. Its stars were incorporated into the ram. The northern fly was never much to look at. Its brightest star is too faint to see from a modern city. It's known as 41 Ariatis. It's actually a triple system, 3 stars bound by their mutual gravity. 2 stars form a type pair with a third star a good distance away from them. The leading member of the system is bigger than the sun. It's also about 160 times brighter, which is why the system is visible at all from its distance of 166 light years. The ghost of the northern fly flutters near the ram, which is halfway up the eastern sky at nightfall. You need dark skies to see any of the fly's faint stars.
So that being said, they're not that faint. They run magnitude 3 to a magnitude 4. So they're still pretty bright in if you get out into dark enough sky. But how do I find it in the sky? Well, if you go up, you look across, you see Taurus. That's easy to find. And Perseus. Come down, make a triangle between the two, and there's a bright star at the end of this line. That's where we're looking, right in here. And here it is. There's the ram. And it's right at his tail. And you know why the flies hung around there. But now this is at 9 o'clock at night if you oriented yourself 210 degrees southwest and it was clear. So what does it look like? Basically, 3 stars. 1, 2, 3. That's exactly what you're looking at with a little bit of a star field in the background. And like Curt says, the Milky Way kind of flows through that area. So there's more stars in there in the background than you think. 10 by 50 binoculars. Well, she's a good size target. Again, 3 bright stars out against the background. So is it difficult to see? Yeah, maybe a little bit. But once you get yourself on this one bright star that's a 3.6, you'll find the other 2. It makes a triangle. And that's where he gets a fly. And I don't see a fly there, but that's what it's called. Compared to the full moon, oh man, what? You can fit 7 full moons in there, 5 to 7. So it's a good size target. All right. So get your binoculars, get out, have a look. And are you ready for this one? Why is an astronaut like a football player? They both want touchdowns. Arr, 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 arr.
Oh, geez.
That's Binocular Target of the Week by Bino Bud.
Yeah. There's
Yeah.
no eyes on you, is there?
No flies on me, man.
Well, I almost used that one in my talk as well.
Did ya?
Because I was going to go with Apis,
Okay.
P-U-S, and I was going to say, well, the plural of that is A-P-E-S, and there's your chimpanzees. But I didn't.
You worked.
Well.
That's good.
Thanks, guys, for keeping it civil.
Could you hear the sound, by the way?
Yeah.
Oh, good.
Couldn't hear the buzzing, but
No, that was in my ear.
yeah.
They
I
call it
get that too.
tendonitis or something. I don't know.
All right. Thanks, Mike, for that. Good target. Derek King says clear skies here in Miramichi for a change.
Yeah, wait for it.
Storm. I would say calm before the storm. Yeah, not going to last long. Get out there now, Derek. Okay. We have Rosanna's fun fact next, Paul.
You're muted. Ha ha.
Yep.
You're still muted. Ha ha.
Yeah, I know. I just didn't want you to hear me clicking and clicking, clickety, clickety, clickety.
Okay.
All right. So
I
let's
get
see.
that in my ear too.
Yeah, better to lie.
And this is this week's.
Rosanna's Fun Fact.
Hey, welcome back, Rosanna, for another wonderful fun fact. And let's just get right to it. I'm just going to get my notes up, and here we go. So, Rosanna writes, "Hi, Paul. I'm still catching up on some exciting stuff from December, while all around me, there are headlines to give your head a whirl." Now, let me just see if I can get the photos to come up. What would you want? What do I have it? Is that the one? There we go. Okay, so just before Christmas, the Earth's magnetic pole moved. Feast your eyes on this. Hoping to keep tabs on the magnetic north's wandering ways, the World Magnetic Model 2025 was released on December the 17th. It revealed the latest official predicted placement of Earth's magnetic fields. Earth's magnetic North Pole is different from the geographic North Pole. The latter, the so-called true north, directly points toward the geographic North Pole, a fixed point on the Earth's surface located at 90 degrees north latitude. Let me just show you that. There we go. Excuse me, where the Earth's axis of rotation meets the surface. Meanwhile, the magnetic North Pole is an ever-changing point that's dictated by liquid metals sloshing around the Earth's outer core. These molten metals are conductive and in constant motion due to the Earth's planet's rotation and heat-driven convection. In tune with the principles of electromagnetism, the movement creates electric currents which generate a magnetic field with two poles. Since the magnetic poles are consistently moving, albeit very slow, the NOAA and the British Geological Survey, BGS, have regularly revised their models. The new World Magnetic Model High Resolution offers a significant improvement in spatial resolution, approximately 300 kilometers or 186 miles at the equator, compared to the standard model's resolution of 3,300 kilometers or 2,050 miles at the equator. Wow, that's quite an improvement in precision. Let me just shrink that down. There we go. The new version is of timely importance too, as the magnetic North Pole's movement seems to be accelerating. Isn't it? Isn't everything? It is heading to Russia. The ETA is unknown. I'm just glad this news didn't interfere with deliveries from the North Pole's most famous resident. We all know that is. Next on his list, or our list, the planning of humans going to Mars is ramping up with endless brainstorming. This next idea is really thinking outside the box. Obviously, Mars lacks a lot of the key materials we need for survival on the planet, such as those to build homes. Never mind the small detail of breathable air. So here's an idea. The Roman solution: we could make homes on Mars by harvesting human blood. A team recently submitted a paper that outlines various methods of creating concrete, and one of those viable is made from Mars regolith and human blood. This astrocrete actually has impressive compressive strength. A member of the team explains, after the arrival of the first Martian inhabitants and their placement in primary structures, which can include inflatable structures, the combination of tears, blood, and sweat from the inhabitants, along with Martian regolith, can be used to produce a concrete known as astrocrete. The production process is simple. Aggregates Martian regolith bind together with through contact with human serum, albumin, HAS, a protein found in blood plasma. And I know you are wondering, and yes, Virginia urine can also be used and might be more freely provided than blood. Now, the most recent surprise in my inbox. These Martian kidney beans aren't safe to eat. They're actually frozen in the northern hemisphere. A recently released photo by NASA's Mars Reconnaissance Orbiter shows a top-down view of the frosty legume lookalikes. And I'm going to have to make this bigger because part of this stuff went away on me. Taken to help scientists determine if conditions of the red planet could have sustained life a long time ago. In the photo, the dunes appear surprisingly motionless. Dunes on both Mars and Earth usually migrate as wind picks up grains of sand from one side of the dune and drops them off at another, making desert look like a slow motion sea. However, the dunes in the photo are covered in large layer of carbon dioxide, frost during the northern hemisphere winter on Mars. The frost stops wind from scooping up sand, preventing the dunes from migrating until the spring thaw comes. After reading this, I think I need some chili from Tim's. And that's this week's
Rosanna's Fun Fact.
Hey. There you go. Thank you so much for that absolutely interesting fun fact.
Wow.
And I'm hungry.
We're going to build a Mars base using blood, sweat, and tears.
What goes up must come down.
Yeah,
Okay, let's take 8 astronauts to Mars. When are you going to get who's going to get sacrificed for building our building?
right.
There's this conspiracy theory that just started now. The Russians have this giant magnet that is taking the magnetic north pole of the Earth, moving it over toward Russia, and they're going to hold it for ransom.
Pretty easy on a flat Earth, I think.
Didn't they just find out that they think there's another molten core in there, like 2 molten cores
Yeah.
or something?
Are you pulling my leg?
It might be the piece of the Theia that collided with the early Earth.
Yeah.
Yeah, I think that was it, or maybe just a large asteroid that hit early on or something.
I just read something about it saying they
Yeah.
think now there's 2 cores.
Maybe we should take a poll.
Oh, gee. I better get on to these pretty quick before
Hurry up.
things go downstream here pretty quick. Okay.
Oh my. What you got, Chris?
Just 1 second here. Yeah, coming up to it.
Time's up.
Okay. No. Okay, photos over there, and I just need to get my notes. And they are right here. Here. Screen 3, and then I got to share screen number 2. Yeah, let's go with this one. Up there, good.
Ta-da!
Hey, there we go. Okay, now this one comes in from David Hoskin. David says, hi, Chris. He said, this image may be of interest. North polar ice cap is prominent. I think he took this on opposition.
Are their poles moving too?
Yeah.
Nice shot.
Yeah, you caught that nice, didn't he?
Yeah. It's a tough one to image, for sure. Nice job, David.
Somebody's holding a spotlight on it, big flashlight.
That is.
Jim Waters sent this one in. Jim says, Comet Atlas, first visible at 6:13, just before sunset. At 6:27, it started getting dimmer, and by 6:32, you could barely see it. So there it is, right there.
Oh yeah.
Oh, it is up. Okay.
You did get it.
Right on.
Now, apparently, it is showing up the southern hemisphere. It's at magnitude -1 right now, I think. -1 or -2.
Right on.
So it is brightening, but nice to go on there, Jim. Good
Yeah.
stuff.
I'm going to have to go out and get it.
Yeah. Now we know where it is,
I
roughly.
think it's actually dimming now.
Okay.
Don't say that.
He said it was getting quite dim as it, when it get down into the thicker part of the atmosphere
Yeah.
too. Didn't help. Okay. Thanks, Jim. Going to go on to Robert Gadet's picture of the NGC 2175, the Monkey Head Nebula. In the constellation of Orion. This is a 1 hour exposure with the C-Star S50, processed in serial with the Hubble palette and Gray Expert and Photoshop.
There you go. Nice.
Done.
I do see a monkey.
Yep.
Right.
There. All right.
That's the chimpanzees off the arc.
Okay. Let's move to Kathy Adams' capture here of the Heart Nebula. Kathy's I see 1805 with my Dwarf 3, she says, approximately 2 hours EQ mode, 30-second subs gain to 60, stacked and begin processing in serial, followed by Photoshop. It was nice to get out again.
There you go.
There.
Those few nights that you do get out and see things, it really is nice. It was really nice at the beach the other night. Just taking a look at everything as well.
Yeah, there's a lot of stuff going on in that photo, eh?
Oh, yeah.
It's especially at that scale.
Yeah.
You got the malot, you got the fish head, You got the whole heart itself. Very nice. Nice work.
Nice work. Okay, another one here from Kathy. On the 17th of January, the waning gibbous moon
Sure. She was pretty.
with her dwarf 3 as well. Yeah, nice capture for.
That's the work 3 works really good, doesn't it?
Doesn't
It
ever.
does.
Yeah.
Lots of detail. Thanks, Kathy. All right, going to go from there to Chris Benoit's capture here of the bubble nebula with his Sea Star S50.
Gonna rename that the Marble.
Yeah.
Oh, yeah.
Nice,
Yeah.
Chris.
Nice shot.
Um, David Smart's capture here of his capture of the monkey head. He said last night, NGC 2175 from Orion constellation, 50 minutes of stacking, no processing yet. So
There you go, man.
data to get it, but that's pretty good for the data.
Yeah.
Nicely done.
Nice done, Dave.
And David also sent in this one some sunspots, he said, from today.
Yeah, they're coming.
They
Well,
are
she's active, eh?
Still active.
getting active again. Yeah. This one now is just directly facing Earth, and it's got a beta gamma delta magnetic field. So it's about ready to let something go, apparently.
It'd be nice if it did it right about now while it's facing us.
Yeah, and then by Tuesday or so, Tuesday's supposed to be clear sky for us, so Tuesday and Thursday, so maybe we'll see something happening. Keep an eye, or I'll keep you posted. Nice shot though.
Hmm.
Brad Perry's capture here. Brad had this up on a Facebook group. I snapped it, so take a look. Peniac NB, January 17th, 2025, from 8:34 to 9:08.
Yeah, nice star trails, eh?
Yeah.
Long exposure, get those light trails on the highway.
Yeah, he does a nice photo.
Oh,
He composes it just right. Good job, Brad.
Yeah. very good.
Got this one from Erica Allison. She caught this in the night skies on Tuesday evening. So she got some nice sun pillars here.
Oh, it's got some pillars.
Yeah.
Yeah,
Beauty.
well done. Thanks, Erica. She shared that on my page earlier. Got this one here from who's this from? Joey Craswell. Joey says there are so many cool things to see when you lose long exposure on our night sky. This one's called the Baby Eagle Nebula. Logged as LB.
Oh, yeah, I can see it. Yeah. It took me a while, but yeah, there it is.
There it is. Yeah.
I see a big nose with two holes.
Yeah.
Oh, there's a beak. There's a beak and the big eye.
Yeah.
Oh, there. If I look that way. Okay. Yeah.
Yeah, there he is.
That's awesome.
That's
Yeah,
awesome.
Baby Eagle Nebula, cataloged as LBN 777. It is a dark reflection nebula made of cosmic dust and molecular gas. The dust reflects the light from stars inside and near the nebula. About 2.5 hours of exposure time, he said, through my telescope. Fantastic. Nice to
Right
like
on.
it done, Joey.
I've never seen that target before. That's awesome.
Yeah. Nice stuff.
Yeah.
All right, and go from there to the lunar occultation of Mars. So this one comes from Lisa Ann Fanning here. She said, once in a while we get lucky in New Jersey. So there it is. She got she captured the whole event.
Yeah.
Oh, nice. Look at that sequence.
They done, yeah.
Did she get it coming out the other side? I wonder.
She didn't say, but you got this side for sure.
Oh, that's fantastic.
Yeah. Well done.
Very
And,
nice.
Also, Stefan Picard caught it here as well. Here's
That's on the
Stefan's
backside.
capture. There's right up there. Yeah.
Oh,
Nicely
look
done,
at
Stefan.
that.
Yeah, I caught it the other side. There you go.
It was too cloudy here.
It was.
Yeah, we couldn't see a thing here. That's fantastic.
Nice, yeah. Mike Powell's capture of our waning gibbous moon at illumination of 86%. Mike,
There you go.
what you use for camera there?
That's my Canon R6 Mark II and my 150 to 600 lens.
Nice.
Very nice.
Nicely done.
That's a nice setup. It works well.
Go back to a memory here from Paul. Mercury
yeah.
Transit Paul. Yeah.
I guess we should
Yeah.
probably straighten out some dates on this because I had it wrong.
Okay.
I thought we did this in 2019 or 2020, but I guess it was earlier in the Curt. Do you remember when that was?
I could look it up in my books, but I'm thinking around 2017.
Yeah, okay. Because what happened when I posted that photo, I posted it and I posted the wrong dates on it, but what I was looking at was the metadata on my photograph from Photoshop, and that was the date I had reposted that before. And anyway, so I made a mistake on that. So it was 2017 because I think Al Dyer chimed in on it, and he said 2017.
Yeah.
And I
Yeah.
remember that morning because it snowed in St. John
It
the
did.
morning
Yeah.
that transit was to happen.
Yeah.
Everybody took the day off to be there at the,
Yeah.
at the
So it
park.
wasn't July for sure.
No,
But,
And
no,
then
it
I
was
got
like
home
June
and I said,
3rd or something.
yeah, and then I got home and it was 9:30 in the morning. And I
Yeah.
got home and I said, I'm going to give it a try. I threw the scope out and we just hit that little break in the cloud and bang, I got it.
yeah. Nicely
Yeah.
done.
But yeah, the Mercury transit, for those who didn't know what that was.
Yeah, that's pretty cool. Nice, Paul. 17 times a century, is that right, Kurt?
13, I think.
13 times a century, it happens.
There's a lucky number for you.
Yeah. Mike and I were down to St. Trust Beach the other night there, so I'm just talking about this is just from my phone, but there's Venus and Saturn together.
Yeah.
They closed in.
They were pretty.
They were pretty, yeah.
Was that phone works good, Chris?
Yeah, it does take a nice sky shot. I hate to get rid of it. It's
Really
wild.
nice.
I hate to get rid of it and switch over to Samsung because I just haven't seen the luck with Samsung that I've gotten with this one. This was, I mean, that was dark, and I set that up on night mode, and it just caught everything. So
Oh, you got everything. You got that beautiful sky right down to the horizon and everything. It's a
Oh.
nice shot.
just for a phone.
Yeah, no, well done.
But anyway, that was nice to enjoy. I mean, this now, of course, Saturn's dropping lower. Venus is getting a little bit higher actually, so they're going to drift apart. But we still have some time to catch the two of them together. So get out there and take a look when you get a clear sky, for sure. And if you have any photos you'd like to share, you can always send them in to astronomybythebay@gmail.com. We love getting them and we love sharing them. So send them in there and we'll put them up on our next broadcast. Quickly through, I'm not going to get into any real events. I just want to get into the calendars that are supplied or sent to me. This one is, of course, from Lisa's Lookup, Astronomy and More. You can find her on Facebook, Instagram, Mastodon, and Threads, now on Blue Sky. So Lisa puts out this monthly calendar. Here's her January calendar. These are the events listed in this column on the left, the dates of the event, the peak times, the best times to see them, and what you need to see it with, naked eye, binoculars, or a telescope. So thanks again, Lisa, for that. Moving from there to Lisa's other announcement here, she has check out the highlights for 2025. There's a link on her Facebook page, and you can get a downloadable copy, print it up, put it up in your fridge, and keep an eye on what's coming up over the next, the best events that are coming up for 2025, including the total lunar eclipse and the partial solar eclipse coming up in March.
Yeah.
That's our big events, I think, for this year. And Kurt puts out this great calendar. What's that?
No, sorry, go ahead.
Okay. Kurt puts out this great calendar for us. Nice 6-week calendar here. 6 weeks? Yeah, pretty well. Brought for January, February. Of course, we're into this week right now, so we're into some nice transits here of some of the moons passing in front of Jupiter. Jupiter's at prime viewing right now, so if you get a clear night, get out and take a look with a pair of binoculars or a small telescope. Share it with the kids. Get them to see how the moons move each night. Celestial mechanics in action there, so it's a great thing to share with the family. So you can find that calendar at sjaastronomy.ca. You can download it right from the page. I think that's all I got.
You look at February 9th in that calendar.
What's that?
Look at February 9th.
Yeah.
Perhaps it's a real challenge, but we might be able to catch Mars coming out of a occultation of the moon
Oh,
in the afternoon, and it's about 3 degrees high.
Wow.
oh wow, that's low. Yeah, that's a challenge.
It's a challenge.
Yeah. Let us know if you get
Well,
that one.
In answer to your question, Paul, Lisa said no, she didn't get it coming off the other side. She went to bed.
Oh, did-
Well, can't blame her for sure.
No.
No.
Yeah. Nice either way.
Yeah, that's right. Okay. Well, I guess we're gonna,
When was the last full lunar eclipse?
A few years ago.
The one that we did 2015. There was one after that, was there?
Yeah, at least one, probably a couple, because usually you get them, you might get 3 or 4 in a couple of years.
Yeah. The
And
one,
it's
the
been,
one in 2015, I think, was they call it a supermoon, but because it was one of the larger moons.
yeah, and it's also the harvest moon.
Right.
yeah. Ours coming up, yeah, on the 14th and the 29th. So they're 15 kind of, well, not really 15 days apart, kind of goes from the 14th into the 15th for the lunar. So they're, yeah, those are the exciting events, I think, coming up anyway for the year. Okay, so anyway, that's our show for this evening. Hope that you enjoyed the program tonight. Special thanks goes out to our special guest again tonight, Curt Nason. Thank you.
My
Curt,
pleasure.
once more. Pleasure having you on the program. Like to have you back again next month.
Okay, it's a date.
Sounds great. Special thanks too goes out once again to Rosanna for another interesting fun facts. Rosanna, thanks very much for sticking with us all this time and all your interesting articles. Special thanks to go out to all of you who share our program first. Lots of shares tonight. Had about 35 or 40 shares.
Oh, nice.
Mark Fitkin shares it a lot for us now. The Bronte Astronomer. We've got Trudy, of course, shares it dozens of places for us. So she's been our main stay right along the way. So thank you everyone for sharing it for us. We do appreciate that. Remember too, we do love getting your photos. So send them in to astronomybythebay@gmail.com and we'll be happy to put them on our next broadcast. So until next week, wishing you all very clear skies. Maybe not tonight, but Tuesday night and Thursday night looks like locally anyway. And as we like to say, guys, open your eyes to view the skies and keep your scopes lit up. Good night, everyone. Thanks for joining us. And I think I'll go over here and say share. Maybe we can sign out. Oh, maybe sign out now this way.